Okay, so today I'm going to explain problem 1 from exam 1 for physics exam. So we have an object's position and velocity at time d, f, and e. So we start with d, then f, and then e. So the first thing we're asked is, what is the position vector at location d? So we have no information about the location of d, so we just have 3 question marks here. So what we need is more information. So the first answer is 10. So we need more information to know the position vector of d. Next, we're asked the change in position between d and f. So we're asked, how does the object move? So we have from d to f. So the second answer is 8. Next, we're asked the change in velocity between d and f. So what we do for that is put the two vectors together like this. We draw f, and then we draw d, but just the other way because it's a minus d. And then the change will be this, which is 7. So we have the change in velocity is 7. Then we're asked the change in momentum, which is also 7, because the change in velocity vector is always equal to the change in momentum. Then we're asked the change in force, which is also equal. And then we're asked to do the same procedure, but from D to E. So we're asked in the first of the true and false, if the displacement vector always is always different from the average velocity, and we know that is false because we have this formula which tells us that the displacement is equal to the average velocity times the time. So we know that the average velocity vector is always equal to the displacement vector, so that's false. Next, we're asked if the momentum vector is equal to the acceleration, which we know is false, because we can have an object move this way with an acceleration this way, so that's false. Next, we have if an object's momentum can be different to the net force. And that's false because we have this formula which shows us that the momentum is equal to the net force times the time. So these are always equal. So this is false as well. Next, we're asked if the momentum vector is always equal to the instantaneous velocity. And we know that's always true because of this. Formula. And last, we're asked if the net force is always constant, then the momentum is constant. And we know that because of this formula.